solve an absolute value inequality. So first, let's consider the inequality x is greater than 3. Well, sometimes it's easiest to think of this represented on a number line. If we want values greater than 3, we would have an open circle at 3 with an arrow pointing to the right, because to the right measures all the values greater than 3. And don't forget, we talk about open circles, closed circles. Because it's greater than, 3 is not a solution, so it has to be an open circle. Okay, great. Interval notation, that'd be 3, comma, infinity with parentheses. Again, the parenthesis, not the bracket, because of an open circle. That's kind of our review. Now let's go ahead and solve the inequality. The absolute value of x is greater than or equal to 2. Well, the basic idea is that this is asking for all the values of x that are 2 units from 0. Because remember, the absolute value is talking distance from 0. So we can represent this by the inequality. Negative 2 is less than or equal to x, which is less than or equal to 2. Right? Both sides of x being by 2. Okay, so we can separate this into two inequalities. Either x is greater than or equal to 2, which is basically what we were given, or x is less than or equal to negative 2. Now, I want to kind of think about this and what it looks like from what we started with. Our absolute value of x, well, x greater than or equal to 2 is what we were given if we just remove the absolute value bars. When you think of our second inequality, x is less than or equal to negative 2, when we flipped the sign of the inequality, we flipped the sign of the number. And if you remember, when you're solving inequalities, inequality equations or things, or inequalities, and you divide or multiply by a negative, you flip the sign. So that's kind of the same thing. When I flip the inequality sign, the sign of my number changes as well. Now we can show this graphically. If we're greater than 2, we have a closed circle at 2 going to the right. If we're less than 2, we're a closed circle shaded to the left. In interval notation, we're at negative infinity to negative 2 with a bracket, or 2, comma, infinity. We have brackets because of the closed circles. Now, going just to review the absolute value with inequalities. When we flip the sign, we flip the negative. It's the same thing. So if you can keep that in mind, it makes it easier when you're creating this, these inequalities. So let's go to the next one. If we're solving the inequality 2x minus 3 is less than or equal to 9. Well, first, let's break this up into two inequalities. The first is going to be exactly what we see. 2x minus 3 is less than or equal to 9. The second one, I'm going to flip the sign to make it greater than or equal to, which means I'm also going to flip the sign of the number. So 2x minus 3 is greater than or equal to negative 9. Now, each of these is going to be solved by first adding 3, then dividing by the positive 2 that is in front of x. So I add 3 to each of these. So I would get 2x is less than or equal to 12 on the left, and the other inequality, 2x is greater than or equal to negative 6. Then we divide by 2. So I get the inequalities, x is less than or equal to 6, and x is greater than or equal to negative 3. So graphically, if we're less than 6 but greater than 3, we fall in this area. And therefore, my interval notation would be negative 3 to 6. Because it's got to go in there. Let's do one more. 3 minus, actually I think there's 2 more. The absolute value of x plus 4 is less than or equal to 1. Well, you'll notice on the left side, we have more than just the absolute value bar. So our first job is to isolate the absolute value expression. So my first step is to subtract 3 from both sides. So I have negative absolute value of x plus 4 is less than or equal to negative 2. Divide both sides by negative 1 to get rid of the negative. You'll notice when I divide by a negative, I flipped my absolute value bar. So, or not the absolute value bar, excuse me, the inequality symbol. So now when I write this as two inequalities, I have x plus 4 is greater than or equal to 2, and x plus 4 is less than or equal to negative 2. So it works the same, where when I want to write my second one, I flip the symbol, flip the sign. We subtract 4 from both sides to isolate the variable. So that's going to give me x is greater than or equal to negative 2 and x is less than or equal to negative 6. So when I want to graph these, greater than or equal to negative 2 gives me a closed circle at negative 2 shaded to the right, and x is less than or equal to negative 6 gives me a closed circle at negative 6 shaded to the left. So in interval notation, I've got negative infinity to negative 6. Oh no, these should be brackets. Those parentheses by negative 6 and negative 2 should both be brackets because we do have a closed circle. That is a mistake on my part. Let's see if we can get a pen here and make those brackets. All right, so that makes that one. But it is two pieces. They just should be brackets because of the closed circles. Now our last one. We have the absolute value of x minus 3 is less than or equal to negative 2. Notice the absolute value expression is already isolated, but it shows that it's less than negative 2. Well, the only numbers less than negative 2 are negative. Therefore, the value coming out of the absolute value, we always know that that's positive, right? Because absolute value tells us distance from 0, and distance is always positive. But this is saying that x minus 3 would have to be less than negative 2. But that doesn't work because you can't, x minus 3 has to be positive because it's coming out of the absolute value. But the inequality here is telling us that it has to be less than negative 2, which is not possible. And therefore, we would simply say there is no solution to this absolute value inequality because there is no value of x that we can plug in that when it comes out of the absolute value will be less than or equal to negative 2.